I'm going to go live. Hello and welcome to the DCG development update. We are here today with the core teams, the mobile team, and the platform teams. And we are in a 1 hour session. I'm going to give you an update on what happened in the past 2 weeks. On the development side, in the live chat below, and we will have a dedicated Q&A session at the very end. And please also use a Q or a question prefix so we can filter out the questions that are intended to the Q&A much more easier. Thank you very much. So without further ado, let me also just start the slideshow, and let's start with the platform teams.
Sure. So I'll give a quick overview. Sam here. So Lukas was basically on making sure that TenderDash met all the requirements of withdrawals and a few other improvements that we had. One great news here is that even though withdrawals is still on this overview, we have merged it in today. So withdrawals is done. And we can finally say that. We also finished and merged in the chain lock stuff. So that's also done. And that's one of the things that I was working on in Drive ABCI. There's also some other interesting stories that I worked on in Drive ABCI that I'll bring up later. And Paul was working on strategies. So let's start with TenderDash maintenance. Lukas.
Hi, so part of this sprint I was off, but I managed to do some interesting load testing and stability improvements. It's part of the load testing effort we started with Ivan, but right now Ivan was focused on withdrawals, so I just had some ideas and fixes to do. It's still in progress because that's a long story to get reasonable results here. So we will still need to test that on the DevNet and testnet and see how it goes. Second thing I worked on, we got some feedback from the community in terms of building TenderDash. It was a bit complex in terms of both documentation and requirements. So I applied that feedback, and that was very good feedback to get. Also had some smaller issues like fixing linter issues and building the Docker images for the various platforms. And we also released new development version dev.2, 0.14.0 dev.2 with threshold rows vote extensions for the withdrawals. So basically that was the big task to do withdrawals compatible with, or to do with withdrawal support in TenderDash. So that's pretty much it on my side.
Yeah, thank you, Lukas. We all glad to finally merge in finalizing these roles in our development branch. It was a long story. Thanks everyone. This sprint I joined, guys, to help to wrap it up, and we will tell you today how it was. And Lukas, do you have something to tell about the withdrawal signatures in TenderDash?
Yeah, so I can get a bit technical. What we have in TenderDash is vote extensions, which are basically some messages or some information that can be included into votes that TenderDash nodes send between them. And we use these vote extensions as a way to agree on the withdrawal transactions. So these vote extensions are signed, and based on these signatures, Drive and Core can trust a withdrawal transaction to be accepted by all the nodes. So what we did here was to create a new type of vote extension to have signature format compatible between all the layers: Core, Drive, ABCI, and TenderDash. And that was the main work done here. And it's already released, as I already mentioned, right? So, but this is done, merged, and it's released as a dev version. Once withdrawals are released as stable version, we'll also release TenderDash stable 0.14. That's it.
Thank you, Lucas. So as I already said, this week was more like wrapping up and polishing, fixing the last issues. One of them we listed here as the first item. They're reusing some RPC method to core, and it has some issue with determinism, so we had to provide the height up to which core should provide the status of the asset unlock transaction. So Drive could deterministically decide if this withdrawal is complete or expired. Yeah, there are like many optimizations and refactorings, polishing, cleaning up in code. We implemented many tests, including the integration tests. We have strategy tests for withdrawals and all new functionality and strategies for this type of state transitions. And also the end-to-end tests in test suite. So Igor implemented multiple different scenarios that we could test. Igor has a demo to demonstrate it. By the way, Igor, you ready?
I am. Okay. Hey, everyone. Let's go quickly over a set of test cases that we did for our withdrawal logic. So while I'm talking, I'm gonna run tests, and we should wait for them to complete. It will take a while since tests are depending on the core activity, and basically, in short, we are relying on core chain log heights changes in order to complete the withdrawals. So the very first test is the positive test case, which checks that user can withdraw credits. I didn't show it last time, but we now have a new SDK method, withdraw credits, which accepts identity, amount to withdraw, and core address where the funds should arrive. So in this test, we're basically withdrawing funded amount. We're waiting for chain log height to change. It's happening right now, actually. And after the core chain log height has changed, we're starting to query withdrawal documents related to our identity. So it should be a very first one. So once we have it completed, we are stopping the test, and well, that's basically concludes this particular test case. Yeah, we had all of them finished right away because well, the progress was visible because it works in parallel mode in Mocha, so it doesn't really matter, but yeah, this is the result. What else? Aside from positive test case, we also have a test case that checks if we try to withdraw more than we have on a balance. We do not allow to sign withdrawals with non-critical security keys, non-critical security key. So we are checking that behavior as well. Also, we are making sure that our data trigger works properly in the drive, and user cannot just create withdrawal documents in the system. This particular test checks that. The next data trigger we have is a check that for the status of withdrawal. So basically, user is not allowed to remove his withdrawals unless they are completed. And finally, we are not allowing to update withdrawal document as well. So yeah, this is the first set of test cases we did. And we have some more plans to add the tests for the indices within the document. Thanks. And yeah, super excited to finally finish this work, which lasted around a month or so for me personally. And yeah, as Sam said last time, we started like a year ago or so. Yeah. Congratulations, everyone, and thank you.
Congrats. Actually, I forgot that we decided that I will go with the SAM diagram first. I made a SAM diagram for you guys just in 15 minutes before the demo, so it looks a bit ugly. I'm sorry, but I really want to explain how it works underneath. And where is that?
15 minutes before,
Shows.
that's fun we love.
What about?
Let's go. Let's see.
Okay, cool. So to understand how withdrawals works, we need to understand how actually the funding works, right? And this is part of the whole process of circulating credits and Dash in Dash ecosystem. So let's start with the funding creating identity. We have a SDK. Let's assume that this square is the client, some application, and first thing that it should do is to create asset log transaction and broadcast it to the payment chain. In this example, the client broadcasts the transaction directly to the chain and reads from the chain. There are other cases where we use DAPI for that. If we do the JavaScript, like web client, but both options are available. So we broadcast asset log transaction. It gets into the payment chain. Either it's instant logged or we're waiting for the chain log and get back the proof that this asset log is actually exist on the chain. Having this proof that we locked some credits on the payment chain, we create an identity, state transition is this proof, and broadcast it through the DAPI to the platform chain. A platform chain, this basically Tender Dash plus Drive and like our ABCI logic consensus. So DAPI just proxy this state transition into platform chain. It gets in the block, and as a result, in the state we have identity, and also we have our total credit balance. We talked about it a lot. It's this feature based on the sum trees in GrowthDB that allow us to calculate and the all balances, so like the all identity balances, and make sure and compare with the system credits, how many credits we actually moved to the platform with identity funding, so we can check if there are any inflationary bugs happened. There were some actually. Yes, so this is identity funding. So at the end, we have identities credits and we have total credit balance. So we know how much credits was actually minted on the platform. Then, for example, you're a master owner and you're getting fees from other identities for processing of state transaction and storage, or you got some credit transfer from another identity, and then you want to withdraw your money back to the Dash. So again, everything started from client, from SDK, and first step is to create withdrawal state transition that you specify the amount, how many credits you want to withdraw. There are some additional, I would say, some system params to make your withdrawal cheaper. We call it like pooling. I will talk about it a bit later. So yeah, your state transition, your request to withdraw goes to DAPI. Then it's also processing in the platform chain. And as a result, we create a document withdrawal document in the withdrawal system contract. It's another system contract such as DPNS, DashPay. What else do we have? Master on reward shares. Yeah, this is withdrawal. And this contract represents the current withdrawals in the system and their statuses. So every client may see what is going on with his withdrawal. That's what actually when Igor is explained that some use case, some test cases related to the contract, that was about it, and data triggers. So data triggers protect this contract to be updated outside of the withdrawal logic. So this system contract is updated only by drive, basically by consensus logic. And from user perspective, it's just for read information and then refund money for withdrawal. We'll talk about it later. So yeah, we have withdrawal in the contract. And then step 5, we every block, we pulling withdrawals into transactions in the queue. Let me explain what is this. So to process withdrawals, we need to create some records, some information basically on platform chain. For that, we're using the asset unlock transactions. And this asset unlock transaction saying like, okay, unlock me this amount from the credits pool of the payment chain, some locked before the credits, and move it to transfer it to specific address. So the pooling is the mechanism that allow to aggregate multiple withdrawals and create one transaction for multiple withdrawals if they fits for specific requirements. So you can specify I want to withdraw now, or I'm ready to wait for some time. And in this case, if the fee, the credit, the core fee is set for withdrawals, what a person ready to spend, I'm matching with other people, then such withdrawals are grouping into one transaction. So you have to pay less fees. I have to say that we implemented at this moment for version 1 of the platform, we go with the pooling setting none. So basically do withdrawal immediately without pooling. And we're gonna come back to this mechanism after the first release of the platform. But just announcing why we have this pooling word here. So then we creating this transaction, but it's not actually complete transaction. That's why it's called untied. It doesn't contain information about the quorum and height when we signing this transaction. So it's more like transaction without actually relation to the moment of signing. But it contains the amount, how many we want to withdraw, and outputs and everything. And such transactions, they pulled in the queue. The special queue with the set of transaction is introduced in security, due to security concerns and the logic how we're signing, and it gives us additional reliability. So basically, when we create this transaction, there is no way that we can modify them. And another thing that this queue allows us to the next block. It doesn't matter who proposed it, and it doesn't matter how many rounds will we have. It guarantees that only this specific set of transactions will be signed. And this is very important to protect from the, how we call it, this type of attack. Then you can collect the signature shares from different rounds. And even if you don't have successful block execution, you can still basically recover the signature. Yeah, and actually the important information that every transaction has an index. So all transactions are indexed, and these indices are verified on different steps of the process, including the core. So we guarantee that there is no any different transactions with the same index, which is important as well. So yeah, and on the next block, we DQ, currently we DQ 16 transactions per block. This is basically the limit what we want to set for load on the core. And Sam, remind me please, why we have this limit?
We have the limit to have an additional protection, basically, and the limit is only going to be active for a certain amount of time. When we launch platform we haven't yet decided, but for the first few months, we're going to have a limit on the amount that you can withdraw from platform. The limit will be pretty high, right? We're talking multiple thousand. I think it's 2,500 dash per day, or Pasta, do you remember the limit?
No, I do not remember what we decided.
It's something about it. But actually, Sam, I was talking about different limit.
Oh, which limit?
I was asking about the limit 16 transactions per block what we broadcast to the core.
Oh, yeah. So we pool documents together generally. And I do actually believe we do pool. We just pool directly. So we have an immediate pooling. I hope that code is still in there. Maybe it isn't, but it should have been in there. And then once the transaction, so that gives you 16 times 16 per block, and it gives you 16 times 16, somebody 169. No, more than that.
Yeah, currently we are
tired.
We have this immediate pooling, that's for sure. And yeah, so basically we have this limit to broadcast 16 transactions at the moment to the core, and so we DQ the 16 transactions, and then this interesting part is happening when we append some context information to the transaction. Is basically the current core height synchronized in platform and current quorum, validator set quorum. And we passing these transactions to the tender dash. The system what Lukasz already mentioned, these vote extensions, that's basically functionality what we are using in tender dash to time withdrawal transactions as well. So together with votes, these transactions are exchanging between the validators, and they are signing them. And at the end, when the block is finalized, we're having the signatures for the quorum, current validator set quorum signature on these transactions. This allows us to, on the core side, to verify that this transaction was made by platform. There are several validation rules, including some expiration mechanism. So the transaction that was not mined into the payment chain during the 48 blocks, we consider as expired, and we're going to have some retry mechanism in such cases. So yeah, basically we broadcast these transactions to the core verifies them, and hopefully including the block. And the second part of the schema, the step 11 and 12, is basically some polling logic on the drive side. We're checking the withdrawal transactions by indices and see if they are chain locked already or not. And if they chain locked, then we mark such withdrawals, the corresponding withdrawals, as complete. And if we see that 48 blocks passed and the transaction is not chain locked or it missed at all, we mark such withdrawal as expired. And SDK, using the fetch documents logic and fetch the status of withdrawals from the contract. You can see the step 13 and 14, and like give me my withdrawals and sort by like latest update time or with specific status and things like this. So it allow us to build the user interface more reliably on the client side and application, so you can evolve it, so you can see all your withdrawals and track the status and react according to it. That's about it. Sam, do you want to add something?
No, I'm just really happy it's over with.
True. Yeah, thank you guys. Let's continue.
Kalash, you want to share again?
Yeah, all right, that's right. You see? Can you see?
Yep.
And
Oh.
Yeah. Hi, guys. I continued working on the strategy tests in the Platform Explorer / the terminal user interface. So picking up from last sprint review, I finished at adding functionality so you can register multiple identities per block. Fixed some other things like I had an issue with credit transfers, and when I pulled V1 dev branch, like the latest branch, into my branch of platform, there was some issues with state transitions where like there was a hash misalignment, like we were broadcasting transitions with single hash and then like looking for the double hash or the other way around. So yeah, fixed that. We had issues with identity state transitions. They were just in the strategy test library. We were only doing, it would only create one like identity update or identity top up or something. It would only create one per block, basically. So fix that. But the big thing that I did this week was switching from running the strategy tests on the testnet to a local network, because on testnet there's like, we were having connection issues and we still kind of are and haven't pinpointed exactly what it is. The nodes might be banning me for trying to stress test the testnet and like submit more than 2 or 3 state transitions per block. So in the past demos I've shown, I've only done like 1 state transition per block. And today I want to just give a quick demo of a strategy test on the local testnet, because you can do like 500 state transitions per block, and it comes out to be like normally if you go over like 1,000 state transitions per minute under the current design of the strategy tests, things will maybe start to break. That could also be, that's not necessarily a platform limitation. It could be a limitation on my design of the strategy tests. So, but yeah, I just want to show that quickly, and that's what I'll do. But going forward, what I'm going to be working on basically starting tomorrow is rapid contract operations. So like registering hundreds of contracts at a time and replacing them and stuff. Right now I have, we have like all identity operations are working, and documents, and you're able to like register contracts, but don't have like rapid registrations. So I'll be looking at adding that this week, as well as document deleting and document replacing. After that, all of like every state transition possible, it will be in strategy tests and working. The only thing is that some of them don't work very fast, namely the identity registration and top up, because you have to like create asset locks to register identities, and that takes a few seconds because you have to wait for core and you have to wait for the UTXOs to replenish. So there's, yeah, there's some things that I can do to make that, to speed that up, but right now it's kind of slow, like doing identity registrations. So let me share my screen and I'll do a quick demo. All right, stop me if you can't see. But again, here's the strategy test part of the terminal user interface. And I have a strategy test called demo loaded. And these are like the fields of the strategy. I'm going to populate operations here. So I'm going to press O. I'm going to press A to add document operation. Oh, I don't have a contract loaded. Okay, hold on. I'm going to have to register a contract really quickly. So I'll do contracts with updates, and actually, no. I'm going to go back to the main page and contracts, fetch system contract, fetch dash pay contract. No, actually, I'm gonna have to register it on the strategies. Okay. So contracts with updates, add. I'm gonna add this one, dash pay contract all mutable. no updates. And I'm just going to run it quickly. Okay, so now this contract is in my local DevNet. Now I'm going to go to operations, add document. This one is the one I just registered, insert random. And I'm going to do 500 times per block. So this is actually the top of the range. So it'll be a random number, like between 1 and 500, how many state transitions or documents it will create per block. I haven't tried 1,000 yet, and I'm not going to try it now because it might break. This honestly might break too, so we'll see. Chance per block 1 is 100. Right now, my platform balance for this identity, you can see at the bottom right, is about 10 dash. My screen froze.
We need that some music like.
Is my screen frozen on yours?
Yeah.
It's okay. This happened last time on the Zoom call. Okay, there we go.
The screen itself is frozen. No, it's not frozen for us. We see it.
Okay. Yeah, you see what just happened?
Yeah. Up there, we see something happened. I think it ran it.
That was when I registered the contract from last run.
Oh, okay.
You see my platform balance is 10 dash, and when you do 500 documents per block, this is going to go down a lot. I think probably by like 4 dash. So
Let's see.
yeah. Okay, so go back, run. Okay, it froze again. Are you okay? There we go. I'm gonna do 10 blocks. Oh, I added this screen too, so you can select the number of blocks to run the strategy. 10, confirm. So this will take probably 30 seconds because it has to do a lot of state transitions. But if you look at the logs, you can see how many it's preparing for each block. And then you can see it's submitting all of these.
I think if this is successful, you're supposed to go up to 1,000.
What do you mean?
Go up from 500 to 1,000 if this is successful.
Oh, okay, sure. Yeah, I mean, it looks like it's working, so.
You want to see your empty wallet.
Oh yeah, my wallet will probably be empty. Actually, I only ran for 10 blocks, so it won't be that much.
Yeah, but the question that I have is why did it go back to like state transition 1 or something? Oh, there we go.
Oh yeah, so the reason it did that, Sam, is because that's straight transition 1 for this block.
Oh, got it.
Yeah.
So you did 1,000.
Yeah, go ahead, Sam.
Yeah, you did 1,400.
Yeah, in 69 seconds, over 10 blocks, and spent 1.16 dash.
Got it. And may I ask, without being mean, what type of computer do you have? Like, how powerful is it?
It's a MacBook Air with the M2.
Got it. That's okay-ish. Pretty good.
Yeah. Okay, should we try 1,000, Sam?
Yeah, sure.
Okay.
I do want the people listening to understand that I think there are 3 or 4 nodes running on one machine. So a real network should be faster with dedicated
Yeah,
hardware.
it's of course. Yeah, of course, because it's also running in Docker and virtual machine, so on Mac.
Yeah.
It's slower.
I am going to move these logs into this actual screen that is on the to-do list.
Yep, that would be nice. Actually, why don't we, because this might take 2 or 3 minutes, why don't we continue and then we'll move back to you.
Yeah, sure.
Good idea.
Okay.
Oh, wait, no. It failed. See?
It failed.
Yeah.
Yeah. So one of the biggest things we have left to do is deal with high amounts. So the system itself doesn't fail. I mean, so it basically fails gracefully. We definitely want to release soon. So we're not trying to, push our limits up very much. We just don't want the system breaking. So if we can get like 100 transactions per second on our mainnet, that's fine. We'll go with 100 transactions per second. I wish it would be more, but for a first version, that's okay for us. But we don't want is that anybody who broadcasts too many state transitions is able to just stop the network. So I just wanted to point that out. I'm also not
right.
saying that we're only going to get 100 transactions per second. We're still we have some few things that we're working on, and once they're done, we'll have a much better idea where we lie there. Okay, let's go continue with me. Okay, I think it's me.
Okay.
Okay, thank you guys.
Yeah,
Thank
so
you,
I've been
Paul.
talking. Thanks, Paul, very much. That was nice. I've been talking a lot about chain lock core synchronization for multiple reviews. I'm just gonna put a pin in it this time. So about where we were last time is we were pretty much close to being done, but we were just running tests on a DevNet to see if things worked. It ended up not working. Then we had to go through about, I mean, me and Latte went through 8 versions with some very small changes each time, and eventually we got it working. And then we ran it for a weekend, and it had no issues whatsoever. Everything was passing. All the optimizations worked, and we merged it in, and that's it. That's done. So I just wanted to say that and move on. Okay. So this is new, cost-based replay attacks. And I'm going to try my best to explain what this is and why it became a very important thing that I was working on for about the last 10 days. So when we normally think about a replay attack, we can think of, okay, a document has a revision, right? And to make sure that it's not replayed, you make sure that the revision isn't like, let's say I have document revision 2, and now I send a state transition that updates it to document revision 3, right? So, okay, I can create my transaction, and there's an update. It says I'm going from 2 to 3 by putting in 3. And then if I tried to do it again, well, the current one in the network would be 3. So, you couldn't be able to replay. And we thought that that was good enough. And then we realized more recently that no, that was not good enough at all. One of the reasons why it's not good enough is because we have something in platform called conflicting state, right? State is actually indexes can be shared between different users, and all the user data is not by itself. So I can make an update like 3 that is proven to not be valid because somebody else took the same resource that I was trying to acquire. So here I wrote down some things for people to remember. State-based validation is expensive in computer resources, and it always needs to be paid for. State transitions must be paid for if they require state validation, even if they fail validation. Otherwise, there's an easy attack on the system, right? So if let's say I have my home set to an address, right? Let's say in a little game, right, that is made in a data contract, only one person can live in one house, right? And they can switch houses, but only one person at one time can live in a house. Now let's imagine that there's a prized house, and me and Balash both want to move there. Yes. And he gets there first. So, but we both issued the state transition at the same time. But his executed first. I am not going to have my state transition work, but I still have to pay for some part of the state validation. Otherwise, I could just spam the network with such requests like nonstop, and it would always require the state validation, which would be expensive and would allow it to DDoS the network. Sorry if this stuff is a little bit advanced. It will. I am trying to make it kind of explainable. So yeah, in the end, I have to pay for it. But let's imagine that, you know, me changing house went from revision of my document, right? Representing you know, where I live in the game, went from version 2 to version 3. Well, version 3 was never actually committed to the state, right? And because it was never committed to the state, let's say some nefarious user such as Pasta, who wants all my money to go away, evil Pasta, decides that he wants to replay my state transition. So what's going to happen is we're just going to have that state transition run again and again and again. I'll never actually get into my dream house because Balash is there, and I'll lose all my money as well. It's so sad. But the real reason for Pasta to replay that attack is that he just wants to attack the network. He's not going to gain any money unless he's maybe an Evo node that is collecting fees. But yeah, so this was something that we noticed in the last 2 weeks, and I was working on it pretty heavily for the last 10 days. So yeah, let's go on to the next slide. Oh, here's another example. User A wants to name Quantum. User B wants to name Quantum. Both submit a state transition at the same time. The failing state transition pays for processing. User C replays the failing state transition. It gets reread and repaid for, rinse and repeat, and again and again and again. And basically, eventually, the failing state transition user just loses all their balance. Okay, next slide. So what was the solution? An identity contract-based nonce. So for every contract, a nonce is stored basically between the identity and the contract pair. Now, we already had a space called contract info in the state for every identity. So every single time an identity does anything vis-a-vis a contract, they bump the nonce. State transitions are broadcast with the intention of having the current nonce be the nonce plus 1. And every time a document state transition occurs, like an add, an update, or a delete, the nonce is verified. Also, a user can make up to 20 state transitions for the same contract per block. Now, this completely solves the issue. The difficulty here was the implementation was a little bit hard, but the good news is that with very tiring work, I kind of got it done. Let's go to the next slide. So most of it's in review as of today. Basically, I had to update all the document state transition to have a nonce. The state transitions that fail state validation still apply their nonce. So even fail state transitions that fail based off of conflicting state, there's multiple ways that you can fail a state transition, right? There's failure of the base structure, the failure of the advanced structure, failure of the identity signature, failure of the state. And the state is generally like making sure that your document doesn't conflict with somebody else. And the state, anything that's state-based validation is much more expensive. Yeah, so we actually changed the order of the validation a little bit. So now we basically do before we had structure validation, identity signature validation, and then state validation. And now we have basic structure validation, which just is very, very quick, very, very small structure validation. Then we have the identity signature validation. We're able to verify the identity signature validation because we did the basic structure validation. And then after that, we have the advanced structure validation and the state validation. Now, the advanced structure validation based off of the state is more like the data contract will tell the document the state that, I mean, the structure that the document needs to be in vis-a-vis the data contract. But that the data contract is actually pulled from the state and is actually pretty expensive to do. So by doing that split, we can push the more expensive thing later down in the process and validate that the nonce is good and that the identity is going to pay for this if it fails or doesn't fail. So like if it fails, it means that the identity was trying to attack the system in the advanced structure solution, or maybe that if he's not trying to attack the system, that he has a very old version of an SDK, possibly. But you know, the SDK should tell the user like that it's old in that situation. So it's most likely an attack. And then it also validates state, which is also an expensive operation. So most of this is done and in review. It's going to need to be reviewed. So I don't expect this to be merged in in the next few days. I expect it to be probably a week from now. But yeah, it's pretty I would say groundbreaking stuff, because I don't actually know of any other project that has this problem because of, you know, how we share secondary indexes among different identities. I don't know of any other project that does that. So this is kind of like a new problem to solve. And I'm very happy that we solved it and it didn't become a big thing. Who
Thank
is
you very
on
much.
this
Ivan?
one?
Oh, right. So we have done a couple more tasks in Drive, more like the fixes. They are related because the platform, the Drive ABCI, the execution logic, has own state, and that's basically what the current height is, and some shared information between the blocks, or even between the steps of the block execution, what we want to store. It's also some denormalized core information from the core, like the quorums to verify signatures and so on. And this platform execution state, not the data itself that's under the tree, they were also serialized and stored on a disk. And we had some chicken and egg problem. So that because protocol version was the current protocol version was stored there. So, and we need to read state to get the version to unserialize the state. So basically, and what we did is just separated the protocol version into additional key, actually existing key what we're already using, and read it first, and then read the rest of the drive data. And we also noticed that during the drive initialization, we have some system data contract cache, the thing what we're using to do not without like, so since these system contracts are using in the block execution and drive processing a lot, like DPNS and withdrawals and so on, we don't want to fetch them all the time, and through the common contract logic, and we have a separate cache for system data contract. So we had the contracts unversioned there, and we dealt with this as well. Yep, that's about it. Core team.
Would you kick us off with core team?
Yeah, for sure. Go ahead and hop over to the next slide. So the biggest kind of thing that I want to report is we are officially done now with what we were calling internally backport January. And so a big focus with January and 20.1 was backports and getting a significant amount done. So version 20 of Bitcoin Core is now completely backported, and significant progress was made in everything from version 21 up to version 24. So we've done a lot of good work there, and that is kind of leading the way to a lot of valuable improvements in the future. The other thing that is very close now is HD wallets by default. So that's kind of in final review right now. I need to spend a little bit more time with it and make sure everything is working as expected. But once that is merged in, we will be releasing 20.1 RC1. And because 20.1 is a little bit more major, I mean, it's not a major release, it doesn't have breaking changes, but there are a lot of backports and there's a lot of changes included in 20.1. So we are going to do a quick release candidate cycle, give people an opportunity to test it and see if we find any issues in testing. And if we don't, then the goal right now is version 20.1 to be released in the next couple of weeks. Maybe next sprint review, I will have an announcement to make releasing it. So be looking forward to that. We've been working towards getting a certificate authority issued code signing certificate, and it's been an absolute pain. Latte has been spending kind of a surprising amount of time trying to really jump through all the hoops that they want. We're moving forward with it, and we're making some progress, but it is annoying and not as trivial as I hoped it was going to be. But Latte is spending some time on that and moving us forward. And so our goal is to have a new certificate for 20.1, but I'm not letting it be a blocker for 20.1. It may or may not happen. Yeah, there's a couple of other small things that we are going to try and get into 20.1 still. Descriptor wallets are relatively close, so that might still make it into 20.1, which is really just kind of technical stuff. It's going to be optional and experimental, so it's not expected for too many people to really use it. But yeah, 20.1 is making good progress. We did bump a couple of things that we've been working on over to the version 21 kind of set of items. So assume UTXO and process separation got moved over there just because it didn't seem like we were going to accomplish them for version 20.1. We're still moving towards them, and there's code related to each of those in 20.1, but the final feature won't really be done for 20.1. So yeah, that's really all I wanted to talk about there. Backports was a huge focus on January, so there's not a ton that I can talk about from that. A lot of it is technical and refactoring based, but still really useful improvements. Yeah, let's move on to the next slide. And briefly, here's just a slide that we had previously, kind of shows the percentages. Really good adoption over on 2004. So we like to see that. Nothing else here really I want to talk about. So we can move on to the next slide again. And here's the list of PRs merged in the last 2 weeks. You can see here there's a lot of backports. So there aren't a ton of PRs that we merged in the last 2 weeks, but each one of these backport PRs is very big. There's 10, 15, 20, 25 commits sometimes. Each one of them is a single backport. So this alone represents probably 100 or 200 backports. So the slide isn't as full this week as I normally like, but there's a lot of work accomplished. So I think that is all from Core's perspective, and we can move on to mobile.
Great, thanks, Basa. All right, so Android, a little light on the sprint, but we did have an issue with that came up pertaining just to Android 6, and when we evaluated that, we found that we had only about a little over 100 users or so. So we deprecated Android 6, and this is a common thing over time, just not supporting every single version of the OSs, but now Android 6 has been deprecated. CoinJoin work continues. The error handling was done, and reliability testing part 2 is almost actually done in the current sprint, but was still in testing at the time. Made some more progress on Maya, the entering of the destination address, and retrieving Coinbase and Uphold addresses that are linked to the wallets. Dash Spend is the new brand that's replacing the old Dash Direct. That's the review of the new API from CTX was being reviewed. That's still in progress. That's kind of one of our priorities beyond just continuing our integration, with the new Rust libraries and whatnot. But as far as a feature perspective, kind of balancing between Maya and Dash Spend. Can move on to the next slide. So a lot of work still, again, continuing on the Rust libraries. I won't get into the nitty-gritties there. It's quite technical, but we finished a couple stories that have been in progress for a little while and created some new ones there. This is all to kind of get our identity system up and running. That's the first priority, so that we can get back onto testnet. The couple bugs, one relating to Coinbase and the Explore Dash merchant sorting, was taken care of, and then again, good work continuing on with CoinJoin on the back end work, and a small fix with the CrowdNode API with the new V20 calculations. Yeah, so that's it for mobile.
All right, thank you very much. And we received a lot of questions. Thanks for that. I would invite Sam to help me out with the questions.
No, you should talk about every single one of them. Don't you agree?
Yeah.
And
Special edition. You can hear my voice. Yeah. Thanks.
It's a very painful voice, it seems like. Okay, so I will go through the questions right now. First question is it possible to transfer stable coins using Dash network? For example, USDT can be transferred with multiple chains, BTC, ETC, Tron, etc. Yeah, so this is actually just something that is done with business development, and we will try to get some stable coins on our network once it's up and running. But yes, it will be definitely possible, technically. New moniker for Paul from research and development. Yes, I agree. He has come far. Question for the nonce discussion. Now that the user would have to pay even failed state transitions, will the user now just query first before submitting state transition to check so it doesn't fit? Now, one thing that I do need to stress is that they only pay for the processing part. And paying for the processing part is, let's say, so small that you will barely notice it. Like, we're talking about microcents. Yeah, so maybe like 0.1 cents, and it's only on the case where a failed state transition happened. Most likely, yes, you would query before submitting, like the SDK would do that for you, but there's still the case that exactly when you submit something, there's a conflict in the state. And we do need to protect against that. You don't pay for storage, but yeah, you do have to pay for the processing, and that's just something that has to happen on our system.
I think we missed one before regarding the stable coins. If it is possible.
Oh, question. Where? Oh, if it is possible. Dash
if it is
network
possible.
have extra money on commissions. Yeah, but that's not really a question. It's more of like yeah. Dash network.
We have this feature, plans for the future. So the data contracts developers will be able to get extra commissions for development and stuff.
Yeah, and tokens as well. So I haven't seen a Dash platform release since the PR releases. When can we expect a 1.0.0 Dev 4, or better yet, a 1.0.0 Alpha 1? Okay, so what we had said last time was that we need to merge in withdrawals first. And guess what? Withdrawals was merged in about an hour and a half ago. So soon, very soon.
I think the most important to explain the strategy now, because we have like multiple pull requests right now merged into V1, and they are breaking change. They contain breaking changes, and we are preparing some release for the testnet, because testnet's still on the version 25. And it's going to be we need to wipe the data, the platform data on it before we deploy. And we don't want to wipe data too often on testnet. So we're trying to grouping such breaking changes together, so we don't need to wipe like every week or so. So we're trying to find the balance to this delivery to the testnet, and also to do not interfere the other developers' work with the wiping testnet too often.
Yeah, that's correct. But I do think it's going to happen very soon, right? Do we have many things in that could you like? We'll probably have a 1.0 this week, right? Is there
I hope so.
That would like stop it? I don't see anything right now, so
Me neither.
probably have like 1.0 dev this week. Alpha, no, we're not yet there. Additionally, for nonce, is the issue mainly deals with documents that have unique properties, right? So not affecting everything. Yes, that is correct. State validation generally is, unique between multiple identities and, having a conflict there. So, or not between multiple identities, between your own identity sometimes, like on multiple devices.
Question
Nice
for
work.
Pasta.
Nice work on the backports. Question for Pasta. Pasta, you want to take your questions, or you want me to speak them out?
Yeah, so the question was basically, are we implementing better tooling for governance voting and like creation of masternode, stuff like that? Yes, that is on our backlog. It's not the highest priority. We don't have anyone who is super skilled with Qt, and so because of that, it just takes more time to kind of get those user interfaces done and looking nice. So it's not a huge priority. It is something that I would like to see accomplished, but there are some bigger line items that I want to get done first.
Okay. Question for Brian Foster. For Maya integration into mobile, what kind of asset swaps will be allowed? Dash to BTC and vice versa, for example?
Yeah.
Noel.
So the current coins supported there, I just pasted in the YouTube chat in case anyone wants to take them down. But there's 3 stable coins: USDC, USDT, and USK. I'm not sure about USK, but it also supports ETH BTC, WSETH, Dash and Rune, obviously, and Kuji.
Okay, well, I think that's all the questions. I do see a big when, and I wish I could answer more. We're just doing our best to finish things as they come. There is 2 things that came up that add work. The one that I was talking about a lot today, I've been working on, that won't add much work because it's going to be merged in soon. We also are going to spend a lot of time in the next month just taking all the data we gathered from the stress test and trying to make improvements there to have the system basically not break on heavy load. So that's going to be a major thing that we're working on soon. As I said, the stress test could show that, we're ready to release, or they could show like additional work is needed. And they did show additional work is needed. It wasn't terrible, but additional work was needed. No, withdrawals are done.
Looks like there was a follow-on question with the Maya integration. So we're not currently planning on having the Dash wallet holds alternate coins. Dash wallet still is only going to be holding Dash. What we're providing for is essentially the way it works is you provide a destination address for whatever you're swapping to. And obviously, if you're swapping from some other coin to Dash, the Dash would come into the Dash wallet. But the idea being that whatever coin you're converting to would go to some other address. There could be a possibility that we could look into, doing something a little bit different, maybe with just one coin potentially, but that's a lot more work. So we wanted to kind of just get a basic version out first. Not sure what you mean by withdrawals. Hopefully that answered the last question about withdrawals. If not, you can try to post another.
Yeah, I think it belongs to the previous one where he gave examples like swaps, LP, withdrawals, like what are the actions that we can do with these assets. But I think you also did.
The primary idea behind this, at least my intent, was to provide some level of stablecoin accessibility, so that, you know, if you could store potentially your holdings in a stablecoin in some other wallet and then easily get it into your Dash wallet if you're going to spend it. And you just do it at the time of spending, basically. That's the general concept.
Okay, well, I think that's all the questions. So
We will be able to upload Maya/Thor key store wallets.
I think my last statement answers that. You might have been typing the question when I was talking about it, but
Yeah,
currently no other coin in the wallet, in the Dash wallet, except Dash for now.
All right, then. Thanks everybody for joining. Thanks for the questions and the comments and feedbacks. And see you in 2 weeks. Wish everybody a great rest of the day. See you guys.
bye.